in this lecture I'll find out the radius of the semicircle. In the drawing we have a semicircle. We also know that line segment PA is tangent to this semicircle at point A. In addition, we know that line segment PA equals to 6 units in its length. Line segment PQ equals to 4 units. And also line segment PS cuts the semicircle at points Q and S. We also know that QS equals to QC. In addition, we know that this is angle PAB that is equal to 90 degrees in its size, and this is angle SQC that is also equals to 90 degrees in its size. Our mission is to find out the radius of this semicircle. So, first of all, I will present to you a new rule and we will implement the new rule in our drawing. The new rule is rule number 10. According to rule number 10, if you have a circle and a common external point P, and from the common external point P, you draw tangent PT that is tangent to the circle at point T, and you draw line segment PB that cuts the circle at point A and B. Then in this drawing, the following equation is true, that PT squared equals to PA times PB. Again, PT squared equals to PA times PB. We can actually implement rule number 10 in our drawing. Why? Because in our drawing we have the common external point P. From the common external point P, we have line segment PA that is tangent to the semicircle at point A, and we also, from the same common external point P, we have line segment PS that cuts the semicircle at points Q and S. So all the requirements of rule number 10 are met. Therefore, we can implement in rule number 10. According to rule number 10, we will get that PA squared equals to PQ times PS. I repeat again. Now, original drawing, according to rule number 10, PA squared equals to PQ times PS. PA equals to 6, therefore PA squared is 6 squared, that is 36, and it is equals to PQ is 4, times PS. What is the length of PS? PS in total equals to PQ plus QS. That is to say, PS equals to PQ, that is 4, plus QS. So in total, PS equals to 4 plus QS. Now, actually, according to rule number 10, we found out that 36 equals to 4 times 4 plus QS. So here we will divide this equation by 4 and we get that according to number 10, 36 over 4 is 9, so 9 equals to 4 plus QS. Here we subtract 4 from this equation, and finally we get that QS equals to 9 minus 4, that is 5. So QS equals to 5 units in its length. So we can write here that chord QS equals to 5 units in its length. But because of the fact that it is given us the question that QS equals to QC and QS equals to 5, therefore QC must be also equal to 5 units in its length. In the next step, I will present to you rule number 3 and we will implement rule number 3 in our drawing. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So in the drawing we have the straight line AB. If you focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of AB at point Q? We have this angle alpha and angle beta. So in total, according to this rule number 3, alpha plus beta must be equal to 180 degrees. So we can actually implement rule number 3 in our drawing. Well, because in our drawing, if you focus on the lower side of PS at point Q, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the lower side of PS at point Q? We have this angle that is equal to 90 degrees plus the missing angle. In total it must be equal to 180 degrees according to rule number 3. Therefore the missing angle here must be equal to 90 degrees. And then in order to complete the sum of the angles the lower side of PS at point Q to 180 degrees, the missing angle here must be equal to 90 degrees. In the next step we will join points P and C together by a straight line. By joining points P and C, we actually created here the right triangle, triangle PQC. So I will copy the right triangle PQC in the new page and we will implement on this right triangle, triangle PQC, the Pythagoras theorem. Here by PT is the progression for Pythagoras theorem. side PQ equals to 4 units in its length, according to what is given as the question. And we just right now found out that QC equals to 5 units in its length. So actually, this is the right triangle PQC that I copied from the original drawing. Again, side PQ equals to 4 and side QC equals to 5. So according to the Pythagoras theorem, in this right triangle PQC, here by PT is a reversion for Pythagoras theorem, so according to the Pythagoras theorem, in this right triangle PQC, PC square equals to PQ square plus QC square. So PC square, that is the square of the hypotenuse, equals to PQ square. PQ is 4, therefore PQ square is 4 squared, that is 16, plus QC square. QC is 5, therefore QC square is 5 squared, that is 25. So in total, PC square equals to 16 plus 25, that is 41. So actually found out that PC square, that is the square of the hypotenuse, equals to 41. In the next step, I will copy the right triangle PAC in a new page, and we will implement in this right triangle PAC the Pythagoras theorem. Again, by PT is the relation for Pythagoras theorem. Side PA equals to 6 units in its length, according to what is given as the question. I repeat again. This is the right triangle PAC that I copied from the original drawing. PA equals to 6 according to what is given as the question. And we have already found out that PC square equals to 41. So in this right triangle PAC, according to the Pythagoras theorem, PC square equals to PA square plus AC square. PC square is 41, so we substitute PC square by 41. And it is equals to PA square. PA is 6, therefore PA square is 6 squared, that is 36, plus AC square. Here we subtract 36 from this equation, and finally we get that AC square equals to 41 minus 36 is 5. AC square equals to 5. Here we take a root out of this equation, and finally we get that AC equals to the square root of 5 units. So here we found out that line segment AC equals to the square root of 5 units in its length. Okay, so we know that this is a semicircle. For that reason, AB must be the diameter of this semicircle. So I write it down. AB is the diameter of the semicircle. So if we define the radius of this semicircle as R, if we define the radius of this semicircle as X, actually, in this question we have to find out the radius of this semicircle, so X is the radius that we are looking for in this question. So if the radius of this semicircle is X, then the diameter AB must be equal to 2X. So I write it down, AB equals to 2X. So what is the length of line segment CB? For the DOM it is very easy to see that CB equals to AB minus AC. That is to say, CB equals to AB, that is 2X, minus AC, that is square root of 5. So I write it down. CB equals to AB minus AC. So CB equals to AB, that is 2X. AB equals to 2X. This is the diameter of the semicircle minus AC. AC equals to the square root of 5 units. So in total we found out that CB equals to 2X minus square root of 5 units. So we can write here that AB equals to 2X minus square root of 5 units. In the next step, we will complete the semicircle to a circle. We completed the semicircle to a circle, and we will extend side QC by a straight line until it touches the circle. We will define the touching point of the extended side QC with this circle SM. In the next step, I will present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule number 11. Rule number 11 is about two chords that intersect with each other inside the circle. According to rule number 11, if we have chord AB, this is chord AB that intersects with chord CD at point O. So whenever we have two chords that intersect with each other inside the circle, like in this drawing, then the following equation will be true. That AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we actually can implement rule number 11 in our drawing. Why? Because in our drawing we have chord AB that intersects with chord QM at point C. Again, chord AB intersects with chord QM at point C. So I write it down. In our original drawing, chord AB intersects with chord QM at point C. repeat again. In our original drawing, chord AB intersects with chord QM at point C. Because of the fact that in our drawing we have two chords that intersect with each other, we can implement here rule number 11. So according to rule number 11, AC times CB equals to QC times CM. Again, AC times CB equals to QC times CM. So I write it down. AC times CB equals to QC times CM. Again, according to rule number 11, AC times CB equals to QC times CM. This will be equation number 1. AC equals to square root of 5 times CB. CB equals to 2x minus square root of 5 and it is equals to QC. QC is 5 times CM. Here we will define the length of this line segment CM as B. So CM is B. So in conclusion, we found out that according to rule number 11, square root of 5 times 2x minus square root of 5 equals to 5b. Here we will divide this equation number 1 by square root of 5. And we get that according to equation number 1, 2x minus square root of 5 equals to 5b over square root of 5. Here we will add to this equation number 1 square root of 5. And we get that according to equation number 1, 2x equals to 5b over square root of 5 plus square root of 5. Repeat again. I found out actually that according to equation number 1, 2x equals to 5b over square root of 5 plus square root of 5. Here we will multiply square root of 5 by square root of 5 and then we will divide it by square root of 5 in order to overcome a factor of this expression. And we get that according to equation number 1, 2x equals to 5b over square root of 5 plus we will multiply square root of 5 by square root of 5 and then we will divide it by square root of 5, so it changes nothing. So actually according to equation number 1 we found that 2x equals to 5 plus square root of 5 times square root of 5 is 5 for 2x equals to 5b plus square root of 5 times square root of 5 is 5, all divided by square root of 5. Again, according to equation number 1, 2x equals to 5b plus 5 over square root of 5. Here we'll divide this equation number 1 by 2. And finally, we will get that according to equation number 1, x equals to 5b plus 5 over 2 times square root of 5. I remind you that x is the radius of the semicircle, that is the radius that we are looking for in this question. So we succeeded to express the value of x in terms of b. So in the next step we will join points S and M together by a straight line. So in the drawing we have peripheral angle MQS. This is peripheral angle MQS that is equal to 90 degrees. So I write it down. Peripheral angle MQS equals to 90 degrees in its size. And we actually have rule number 5 that relates to a peripheral angle that is equals to 90 degrees in its size. According to rule number 5, any peripheral angle that is equals to 90 degrees must rest on the diameter of the circle. In the drawing we have a circle. Inside this circle we have peripheral angle MAN. This is peripheral angle MAN that is equals to 90 degrees in its size. So according to this rule number 5, peripheral angle MAN that is equal to 90 degrees in its size must rest on the diameter of the circle. From the drawing itself, it is very easy to see that peripheral angle MAN rests on chord MN. Therefore, according to rule number 5, chord MN must be the diameter of the circle. And from the drawing itself, you can see that MN is indeed the diameter of the circle. Why? Because chord MN passes through point O, that is the center of the circle, and any chord that passes through the center of the circle must be the diameter of the circle. So you can summarize and say that because of the fact that peripheral angle MAN equals to 90 degrees in size, therefore it must rest on the diameter of the circle. Here you can see that peripheral angle MAN rests on MN, that is the diameter of the circle. So we can actually implement rule number 5 in our drawing. In our drawing we have peripheral angle MQS that is equal to 90 degrees in size. Therefore, according to rule number 5, here peripheral angle MQS equals to 90 degrees in size. Therefore, according to rule number 5, peripheral angle MQS rests on the diameter of the circle. From the drawing itself, it is very easy to see that peripheral angle MQS rests on MS. Therefore, according to rule number 5, chord MS must be the diameter of the circle. So I will write it down. according to rule number 5, ms is the diameter of the circle. According to our definition, the radius of the circle is x, therefore the diameter ms must be equal to 2x. So here, ms equals to 2x. It's twice as long as the radius. Repeat again. ms is the diameter of the circle and it is equals to 2x units in its length. In the next step, I will copy the right triangle MQS in a new page and we will implement on this right triangle MQS the Pythagoras theorem. Again, by PT is the progression from Pythagoras theorem. So actually, this is the right triangle QSM that I copied from the original drawing. Side QS, this is side QS, is equals to 5 units in its length. What is the length of side QM? From the drawing it is very easy to see that QM equals to QC plus CM. That is to say QM in total equals to QC, that is 5, plus CM, that is B. So in total, QM equals to 5 plus B. QM equals to 5 plus B. And what is the length of the hypotenuse SM? We have already found out that the hypotenuse SM is also the diameter of the circle, that is equals to 2x. So SM equals to 2x. So in this right triangle QSM, according to the Pythagoras theorem, we get that SM squared, that is the square of the hypotenuse, must be equal to QS squared plus QM squared. In this right triangle QMS, SM squared equals to QS squared plus QM squared. SM is 2x, therefore SM squared is 2x squared. And it is equals to QS squared. QS is 5, therefore QS squared is 5 squared, that is 25. Plus QM squared. QM is 5 plus B, therefore QM squared is 5 plus B squared. In conclusion, we found out that according to equation number 2, 2x squared equals to 25 plus 5 plus B squared. This is according to equation number 2. While according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. So actually we can substitute x in this equation, equation number 2, by the value that we found for x in this equation, equation number 1. According to equation number 1, x equals to 5b plus 5 over 2 times square root of 5. Therefore, we can substitute x in this equation, equation number 2, by 5b plus 5 over 2 times square root of 5. So we'll do it now, and we get that according to equation number 2, 2 times x, and x, according to equation number 1, equals to 5b plus 5 over 2 times square root of 5. So here in equation number 2 we have 2x squared, so it is 2x squared, and it is equals, according to this equation, equals to 25 plus 5 plus b squared. Repeat again. We substitute x in this equation, equation number 1, by 5b plus 5 over 2 times square root of 5. It is 2x squared, that is equals to 25 plus 5 plus b squared. So here, in this side of equation number 2, we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. After we cancel 2, in this side of equation number 2, we left with 5b. In the numerator we have 5b plus 5 squared over, in the denominator we have square root of 5 squared. Square root of 5 squared is 5. So in total, in this side of equation number 2, we have 5b plus 5 squared over 5, and that is equals, on the other side of equation number 2, we have 25 plus 5 plus b squared equals to 5 squared, that is 25, plus b squared plus 2 times 5b, 2 times 5b is 10b. In the next step, we will open the brackets on this side of equation number 2, and we get that according to equation number 2, 5b plus 5 squared equals to 5b squared, that is 25b squared, plus 5 squared, that is 25, plus 2 times 5b is 10b, and 10b times 5 is 50b. So 5b plus 5 squared, in total it is equals to 25b squared plus 25 plus 50b, all divided by 5. It is equals, in the other side of equation number 2, we have 25 plus 25, that is 50, plus b squared plus 10b. Repeat again. According to equation number 2, we found out that 25b squared plus 25 plus 50b over 5 equals to 50 plus b squared plus 10b. So in this side of equation number 2, we have 25b squared over 5 is 5b squared, plus 25 over 5 is 5, plus 50b over 5 is 10b, and it is equals to 50 plus b squared plus 10b. So here we have 10b on both sides of the equation, so 10b will get cancelled. After we cancel 10b, in this side of equation number 2, we left only with 5b squared plus 5, that is equals to, on the other side of the equation, we left only with 50 plus b squared. Here we subtract b squared from this equation number 2, and we get that on this side of equation number 2 we have 5b squared minus b squared is 4b squared, so it is 4b squared plus 5, that is equals to 50. Here we subtract 5 from this equation number 2, and finally we get that according to equation number 2, 4b squared equals to 50 minus 5 is 45. So 4b squared equals to 45. We divide this equation number 2 by 4, and finally we get that according to equation number 2, b squared equals to 45 over 4. Again, according to equation number 2, we found out that b squared equals to 45 over 4. Here we will, so according to equation number 2, b squared equals to 45. 45 is 9 times 5, so we substitute 45 by 9 times 5 over 4. So according to equation number 2, we found out actually that b squared equals to 9 times 5 over 4. Here we take out of this equation number 2, and finally we get that b equals to the square root of 9 times 5 over 4. So actually b equals to the square root of 9 is 3, so 3 over 4, and the square root of 4 is 2, so it is over 2. Inside the root we left only with 5. In conclusion, we found out that b equals to 3 times square root of 5 over 2. So I will write it down again. Actually found out that according to equation number 2, b equals to 3 times square root of 5 over 2. This is according to equation number 2. While according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. Now we can put the value of b that we found in equation number 2 in equation number 1. And we get that according to equation number 1, x equals to 5b. So it is 5 times b according to equation number 2 is 3 times square root of 5 over 2. It's 5b plus 5 over 2 times square root of 5. So according to equation number 1, we actually found out that x equals to 5 times 3 is 15. So in total this expression equals to 15 times square root of 5 over 2 plus 5, all divided by 2 times square root of 5. So according to equation number 1, x equals to 15 times square root of 5 over 2 plus 5. We multiply 5 by 2 and then we divide it by 2 in order to write one factor with this expression. So it is plus 5 times 2 is 10, and then we divide it by 2, so we change nothing. all divided by 2 times square root of 5. Here we'll move 2 times square root of 5 to the denominator, and we get that according to equation number 1, x equals to 15 times square root of 5 plus 10 over 2 times 2 times square root of 5. 2 times square root of 2 times 5 in total equals to 4 times square root of 5. So actually found out that x equals to 15 times square root of 5 plus 10 over 4 times square root of 5. Here we substitute 10 by square root of 5 times square root of 5 times 2, and finally we get that x equals to 15 times square root of 5 plus 10, and 10 is square root of 5 times square root of 5 times 2 over 4 times square root of 5. In the next step, we will take out square root of 5 as a common factor from those two expressions in the numerator, and finally we will get that according to equation number 1, x equals to, so square root of 5 was taken out as a common factor from those two expressions in the numerator. So what is left from square root of 5 times 15 after we took from it square root of 5 is a common factor? What is left? It is actually 15 plus what is left from square root of 5 times square root of 5 times 2 after we took from it square root of 5 is a common factor. What is left? It is actually square root of 5 times 2, all divided by square root of 5 times 4. So in conclusion, we found out actually that x, that is the radius that we are looking for, in total, according to equation number 1, x equals to square root of 5 times 15 plus square root of 5 times 2 over square root of 5 times 4. So we have square root of 5 in the numerator and square root of 5 in the denominator, so square root of 5 will get cancelled. And finally we found out actually that x equals to 15 plus square root of 5 times 2 over 4. I repeat again, I actually found out that the radius of this semicircle, that is x, it is equals to either 15 plus square root of 5 times 2 over 4, or in terms of numbers, the radius x equals to 4.8680 units. And that is the answer to the question. Repeat again, the radius x of this semicircle is equals to either 15 plus square root of 5 times 2 over 4 units, or in terms of numbers, the radius x of this semicircle equals to 4.8680 units. It is a little bit less than 4.9 units. Okay, so in the next step I will summarize the lecture. this lecture we found out the radius of this semicircle. So in the drawing we have a semicircle and we have line segment PA that is tangent to the semicircle here at point A, and we also know that the length of line segment PA is 6, line segment PQ equals to 4 units in its length, and we also know that line segment PS cuts the semicircle at points Q and S. In addition, we know that QS equals to QC, and this is angle PAB that is equal to 90 degrees in size. This is angle SQC that is also equal to 90 degrees in its size. Again, our mission is to find out the radius of this semicircle. Okay. So first of all, I presented to you a new wall. We implemented the new wall in our drawing. The new wall is wall number 10. Wall number 10 is about if we have a common external point, point P. Point P is a common external point in relation to this circle. So if from the common external point P we draw tangent PT that is tangent to this circle at point T, and from the same common external point, point P, we draw line segment PB that cuts the circle at points A and B, then in this drawing the following equation will be true, that PT square equals to PA times PB. Again, PT square equals to PA times PB. We can actually implement rule number 10 in our drawing. Why? Because in our drawing we have the common external point, point P. From the common external point, point P, we have tangent PA that is tangent to this circle point, to the same circle at point A, and we have line segment PS that cuts the semicircle at points Q and S. So all the requirements of rule number 10 are satisfied. Therefore, we can implement it. Rule number 10. According to rule number 10, PA square equals to PQ times PS. Again, PA square equals to PQ times PS. I'll repeat again. If we focus on the common external point, point P, according to rule number 10, PA square equals to PQ times PS. PA is 6, therefore PA square is 6 squared, that is 36, and it is equals to PQ. PQ is 4 times PS. PS from the drawing it is very easy to see that PS in total equals to PQ plus QS. That is to say PS equals to PQ, that is 4 plus QS. So in total PS equals to 4 plus QS. Here PS equals to 4 plus QS. So in conclusion, we found out that according to rule number 10, 36 equals to 4 times 4 plus QS. Here we divided this equation by 4, and finally we get that 36 over 4 is 9, so 9 equals to 4 plus QS. Here we subtract the 4 from this equation, and finally we got that 4, and that QS equals to 9 minus 4, that is 5. Here, this line segment QS equals to 5 units in its length. But because of the fact that it is given us the equation that QS equals to QC and QS is 5, therefore QC must be also equal to 5 units in its length. Then I presented to you rule number 3, and we implemented rule number 3 in our drawing. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. In the drawing we have the straight line AB. So if we focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to this rule, rule number 3. So which angles we have at the upper side of AB at point Q? We have angle alpha and beta. So according to this rule, rule number 3, alpha plus beta must be equal to 180 degrees. We can actually implement rule number 3 in our drawing. Well, because in our drawing, if we focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the lower side of PS at point Q? We have this angle that is equal to 90 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule number 3. Therefore, the missing angle here must be equal to 90 degrees. Again, in order to complete the sum of the angles in the lower side of PS at point Q to 180 degrees, the missing angle here must be equal to 90 degrees. Then we join points P and C together by a straight line. By joining points P and C, we created the right triangle PQC. So I copied the right triangle PQC in the new page and implemented the Pythagoras theorem with this right triangle PQC. This is the right triangle PQC that I copied from the original drawing. Side PQ equals to 4 units in its length according to what is given as the question. We just right now found out that QC equals to 5 units. So in this right triangle by PT is a relation for Pythagoras theorem. In this right triangle PQC according to the Pythagoras theorem, PC square equals to PQ square plus CQ square. So PC square, that is the square of the hypotenuse, equals to PQ square. PQ is 4, therefore PQ square is 4 square, that is 16, plus QC square. QC is 5, therefore QC square is 5 square, that is 25. So in total, PC square equals to 16 plus 25, that is 41. In conclusion, we found out that PC square equals to 41. Then I copied the right triangle PAC in a new page, and we implemented the Pythagoras theorem in this right triangle PAC. This is the right triangle PAC that I copied from the original drawing. Side PA equals to 6 units according to what is given as the question. And we have already found out that PC square equals to 41. By PT is a relation for Pythagoras theorem. According to the Pythagoras theorem, PC square equals to PA square plus AC square. PC square is 41. We substitute PC square by 41. And it is equal to PA square. PA is 6, therefore PA square is 6 squared, that is 36, plus AC square. Here we subtracted 36 from this equation. And finally we found out that AC square equals to 41 minus 36, that is 5. So AC square equals to 5. We took a root out of this equation, and finally we found out that AC, the length of this side AC, equals to the square root of 5 units. So I can write here that AC equals to square root of 5 units in its length. Because of the fact that this is a semicircle, AB must be the diameter of the semicircle. AB must be the diameter. So, if we define the radius of this semicircle as x, the radius is x, according to our definition, then the diameter must be equal to 2x. So the diameter AB of this semicircle equals to 2x units in its length. AB is 2x and AC is equal to 5, so BC in total equals to AB minus AC. Repeat again. In total, CB equals to AB minus AC. That is to say, the length of line segment CB is AB, that is 2x, minus AC, that is equal to 5. So in total, CB equals to 2x minus equal to 5. Repeat again, this line segment CB equals to 2x minus equal to 5. Then we completed this semicircle to a circle, and we extended side QC by a straight line until it touches the circle here. We define the touching point of the extended side QC with this circle as M. Then I presented to you rule number 11, and we implemented rule number 11 in our drawing. Rule number 11 is about two chords that intersect with each other inside the circle. According to rule number 11, rule number 11 is true in any circle, so in the drawing we have chord AB that intersects with chord CD at point O. Again, chord AB intersects with chord CD at point O. So whenever you have two chords inside the circle that intersects with each other, then the following equation will be true, that AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. We can actually implement rule number 11 in our drawing. Why? Because in our drawing we have chord AB that intersects with chord QM at point C. Again, chord AB intersects with chord QM at point C. So, because of the fact that in our drawing we have two chords that intersect with each other, we can implement here rule number 11. According to rule number 11, AC times CB equals to QC times CM. Again, AC times CB equals to QC times CM. Repeat again. In our drawing, we have chord AB that intersects with chord QM at point C. Therefore, according to rule number 11, we will get that AC times CB equals to QC times CM. Again, AC times CB equals to QC times CM. AC is equal to 5 times CB, that is 2x1 is equal to 5, and it is equals to QC, that is 5, and CM equals to B according to our definition. So in conclusion, found out that according to equation number 1 and rule number 11, is equal to 5 times 2x1 is equal to 5 equals to 5b. Here we divided this equation by square root of 5, and finally found out that 2x1 square root of 5 equals to 5b over square root of 5. Here we added square root of 5 to this equation, equation number 1. And finally we found out that 2x equals to 5b over square root of 5 plus square root of 5. Here we multiply square root of 5 by square root of 5, and then we divide it by square root of 5 in order to overcome a factor with this expression. So according to equation number 1, 2x equals to 5b over square root of 5, and plus we multiply square root of 5 by square root of 5, and then we divide it by square root of 5, so we change nothing. So in conclusion, we found out that 2x equals to 5b plus square root of 5 times square root of 5 is 5, all divided by square root of 5. Again, according to equation number 1, 2x equals to 5b plus 5 over square root of 5. Here we divided the equation number 1 by 2, and finally we found out that x equals to 5b plus 5 over 2 times square root of 5. Then we join points S and M together by a straight line. So in the drawing we have peripheral angle SQM that is equal to 90 degrees in its size. And we have rule number 5 that relates to a peripheral angle that is equal to 90 degrees in its size. According to rule number 11, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. In the drawing we have a circle. Inside this circle we have peripheral angle MAN. This peripheral angle MAN equals to 90 degrees in its size. Therefore, according to this rule number 5, this peripheral angle MAN must rest on the diameter of the circle. From the drawing itself, it is very easy to see that peripheral angle MAN rests on chord MN. Therefore, according to this rule number 5, chord MN must be the diameter of the circle. And indeed, it is very easy to see that chord MN is the diameter of the circle. Why? Because of the fact that chord MN passes through point O, that is the center of the circle. And we know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, chord MN is the diameter of the circle. So we can actually implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle MQS that is equal to 90 degrees. We have peripheral angle MQS equals to 90 degrees in size. Therefore, according to rule number 5, this peripheral angle MQS must rest on the diameter of the circle. From the drawing itself, it is very easy to see that peripheral angle MQS rests on chord MS. Therefore, according to rule number 5, chord MS must be the diameter of the circle. Again, according to rule number 5, chord MS must be the diameter of the circle. And because of the fact that the radius of this circle is x, if the radius is x, then therefore the diameter MS must be equal to 2x. Okay, then I copied the right triangle MQS in a new page and implemented the Pythagoras theorem in this right triangle MQS. This is the right triangle MQS that I copied from the original drawing. Side QS equals to 5 units in its length, and side QM equals to QM in total equals to QC plus CM. That is to say, QM equals to QC, that is 5, plus CM, that is B. So in total, QM equals to 5 plus B. Here, QM equals to 5 plus B, and QS equals to 5. And the hypotenuse SM is also the diameter of the circle, that is equal to 2x. According to rule number 5. The hypotenuse SM equals to 2x units in its length. So according to the Pythagoras theorem, in this right triangle QMS, SM square equals to QS square plus QM square. Again, SM square equals to QS square plus QM square. So SM is 2x, therefore SM square is 2x square, and it is equals to QS square. QS is 5, therefore QS square is 5 square, that is 25, plus QM square. QM is 5 plus B, therefore QM square is 5 plus B square. So in conclusion, we found out that according to equation number 2, 2x squared equals to 25 plus 5 plus b squared. This is according to equation number 2. When according to equation number 1, we have already found out that x equals to 5b plus 5 or 2 times square root of 5. Now we can substitute x in this equation number 2, but the value that we found for x in this equation number 1. We did it and we got that here 2x squared. So it is 2 times x. X according to equation number 1 is 5b plus 5 or 2 times root of 5. So it is 2x squared. That is equals to, according to equation number 2, it is equals to 25 plus 5 plus b squared. So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. After we cancel 2, in the numerator we have 5b plus 5 squared over square root of 5 squared. Square root of 5 squared is 5. So in total, this expression equals to, in this side of the equation we have 5b plus 5 squared over 5, that is equals to 25 plus 5 plus b squared. 5 plus b squared equals to 5 squared, that is 25, plus b squared, plus 2 times 5b, that is 10b. Then we open the brackets on this side of equation number 2. 5b plus 5 squared equals to 5b squared, that is 25b squared, plus 5 squared, that is 25, plus 2 times 5b is 10b, and 10b times 5 is 50b. All divided by 5. So in conclusion, this side of equation number 2, we have 25b squared plus 25 plus 50 over 5. That is equals to, in the other side of equation number 2, we have 25 plus 25, that is 50, plus b squared plus 10b. Again, on the other side of equation number 2, we have 50 plus b squared plus 10b. So 25b squared over 5 is 5b squared, 25 over 5 is 5, and 50b over 5 is 10b. And it is equal to 50 plus b squared plus 10b. Here we have 10b on both sides of the equation, so 10b will get cancelled. After cancelling 10b, in this side of the equation we left only with 5b squared plus 5. On the other side of the equation, after we cancel 10b, we left only with 50 plus b squared. In conclusion, found out that according to equation number 2, 5b squared plus 5 equals to 50 plus b squared. We subtract b squared from this equation. And finally we found out that 5b squared minus b squared is 4b squared. So in this side of the equation we have 4b squared plus 5. That is equals to 50. Here we subtracted 5 from this equation, equation number 2. And finally we found out that 4b squared equals to 50 minus 5 is 45. So 4b squared equals to 45, according to this equation number 2. We divided this equation number 2 by 4, and finally we found out that b squared equals to 45 over 4. So b squared equals to 45. 45 is 9 times 5, so we substitute 45 by 9 times 5. divided by 4. Here we took out of this equation number 2, and finally found out that b equals to the square root of 9 times 5 over 2. The square root of 9 is 3, over the square root of 5, that is 2. Inside the root, we left only with 5. So in conclusion, found out that according to equation number 2, b equals to 3 times square root of 5 over 2. I'm repeating again. According to equation number 2, we found out that b equals to 3 times square root of 5 over 2. This is according to equation number 2, while according to equation number 1, we've already found out that x equals to 5b plus 5 over 2 times square root of 5. Now we can put the value of b in this equation number 1. We can put the value that we found in equation number 2 for b in this equation number 1. So x equals to 5b, and b according to equation number 1 is 3 times square root of 5 over 2 plus 5 over 2 times square root of 5. So here we have 5 times 3, that is 15, so in total this expression equals to 15 times square root of 5 over 2 plus 5 over 2 times square root of 5. Here we multiplied 5 by 2 and then we divided by 2 in order to become factor of this expression. So it is x, it is equals to 15 times square root of 5 over 2, and 5 plus 5 times 2 is 10, and divided by 2. So we multiplied 5 by 2 and then we divided by 2, so we changed nothing. So in total, we actually found out that x equals to 15 times square root of 5 over 15 times square root of 5 plus 10 over 2, all divided by 2 times square root of 5. Here we moved 2 times square root of 5 to the denominator, and finally we found out that x equals to 15 times square root of 5 plus 10 over 2 times square root of 5. So x equals to 15 times square root of 5 plus 10, and 2 times square root of 5, in total equals to 4 times square root of 5. So according to equation number 1, x equals to 15 times square root of 5 plus 10 over 4 times square root of 5. Here we substitute 10 by square root of 5 times square root of 5 times 2. Therefore, in total we found out actually that according to equation number 1, x equals to 15 times square root of 5 plus 10 is square root of 5 times square root of 5 over 2, all divided by 4 times square root of 5. Then we took square root of 5 as second factor from those two expressions in the numerator. So square root of 5 is taken out as second factor from those two expressions. What is left from 15 times square root of 5 after we took from it square root of 5 is second factor? What is left is actually 15, and what is left from square root of 5 times square root of 5 over 2 after we took from it square root of 5 is second factor? What is left? It is actually square root of 5 times 2. Repeating again. X equals to square root of 5 is taken out as second factor from the two expressions in the numerator. So inside the brackets we left with 15 plus square root of 5 times 2, all divided by square root of 5 times 4. We have square root of 5 in the numerator and square root of 5 in the denominator, so square root of 5 will get cancelled. And finally, we found out actually that x equals to 15 plus square root of 5 times 2 over 4 units. In terms of numbers, the radius x of this semicircle equals to 4.8680 units in itself. Again, the radius of this semicircle x equals to a little bit less than 4.9 units, or we can say that the radius of this semicircle x equals to 15 times root of 5 times 2 over 4 units. Okay, thank you very much.